Alright, Bismillahirrahmanirrahim. Assalamualaikum. So, today class, we will learn a new subtopic under continuous probability distribution, which is normal distribution. So remember on the last class, last lecture on special probability distribution, we have learned special probability distribution for discrete random variable, where we already learned Bernoulli distribution, binomial distribution, and then we also learned uh, Poisson distribution, right? So for under continuous distribution, right? There are a lot of probability distribution, special probability distribution, such as uniform distribution, normal, chi-squared, exponential, gamma, and variable distribution. But in this class, we only focus on normal distribution, right? We will focus on normal distribution. So for normal distribution, right, let's look at the characteristic of normal distribution. So first, this is the probability distribution curve for normal distribution. Right, it looked like a bell-shaped distribution, right? Bell-shaped curve lah. So a normal distribution is the most used statistical distribution, right? The principal reason is arise naturally in many physical, biological, and social measurement situation, right? So means that we want to measure what is a normal part of the data, right? So normality is important in statistical inference when you want to do a parametric test, such as one-way ANOVA, independent sample t-test, right? Regression, linear regression, and so on, right? So normality means that the data should look like a bell-shaped curve. So we already learned in chapter number 2 how to identify bell-shaped curve. Bell-shaped curve means that it's a symmetrical from left to right, right? And then mean is equal to median is also equal to mode lah. Benar, kalau dekat mean is equal to median mode, and then this is we have a normal distribution. So normal distribution takes two parameter, which is mean, mu, and standard deviation. So mean here the notation is mu, and the standard deviation is sigma, right? So let's look at the characteristic of normal distribution, right? So kalau you nampak dekat sini, we have a bell-shaped curve. This is a normal distribution curve. It's a bell-shaped curve and it's symmetrical about the mean. Means that this the center is our mean. This is mean. Sama juga mean equal to median and mode, right? Symmetrical means that area on the right hand side, the whole area on the right hand side is also equal to the area on the left hand side. Right? Sama saja, area sebelah kiri sama dengan area sebelah kanan. This is a characteristic of normal distribution. And the important part lah. So if you don't remember, you want to remember about normal distribution, you just need to know that area on on the right hand side is equal to area on the right hand side, in the the right hand side. So means that kalau kita nak cari area di sini, this is 2.14% area. So area di sebelah kiri pun sama juga, 2.14%. Means that mu plus 2 sigma, area mu more, maksudnya kalau kita nak cari probability of x more than mu plus 2 sigma is also equal to probability of x less than mu plus mu minus 2 sigma. Sebab area dia sama, right? And then it is asymptotic to the axis. Dekat sini nombor 2. It is asymptotic to exist. It extends indefinitely in either direction from the mean, right? So maksudnya exist dia asymptotic, maksudnya dia dekat bawah ni, kan kita nampak tail dia kan? The tail here, tail ni dia tidak akan touch zero axis. Asymptotic means that dia takkan touch zero axis sampai infinity, and this one sampai negative infinity. Dia tidak akan touch zero, right? Because this is a probability distribution. When probability equal to zero means that there are no event kan. So there definitely has something dekat sini lah. Dia takkan touch zero. So the total area under the curve is equal to 1. Maksudnya the integration from negative infinity to infinity of the fx with respect to x is equal to 1. So the total area under the curve is equal to 1. This is follow a rule of probability lah. And it is unimodal, right? It only have one mode. Unimodal, satu saja yang tinggi, maksudnya satu mode saja. As we already know in previous knowledge, right? Mean is equal to median equal to mode. So there only one mean and one mode, right? They cannot be multimodal or bimodal, right? The probability that random variable will have value between any 2 points equal to the area under the curve between those points lah. So we already learned in last class, right? When you have continuous probability distribution, you cannot find probability of x equal to c. Maksudnya c is any constant lah. X, probability of x equal to 9. There is no point probability. That should be in we should measure the probability between range lah, dalam bentuk range. Maksudnya daripada negative mu minus sigma to mu plus sigma. It should be measured based on area under the curve, right? So this is a continuous probability distribution. We cannot measure point probability. So there are no point probability. So basically, there are 7 characteristics of normal distribution that you should know, right? So yang I highlight merah ni, and this is the most important characteristic that you should remember, right? It's a bell shape, continuous distribution, total area equal to 1, and the probability must be measured based on area under the curve. And another one is on the first characteristic is a symmetrical kan. Maksudnya area on the right hand side is also equal to area on the left hand side, right? It's a symmetrical. Okay. Now let's look at the probability density function for normal distribution. So as you remember in binomial PDF, you're going to have n choose x, probability of x q n n minus x, right? So this is a PDF for binomial distribution, right? So for normal distribution is 1 divided by sigma multiplied with square root of 2 pi multiply with exponential negative x minus mu squared divided by 2. And the range of x is from negative infinity to infinity. So this is a probability density function for normal distribution, right? So this is another important part you should know. And I already emphasized it many times, right? There are no point probability, and the probability should measure in range form. Probability of x between A and B, right? So since this is a continuous distribution, probability of x between A and B inclusive is also equal to probability of x between A and B not inclusive. Dan dia sama saja. So dia tiada perbezaan macam kita tengok dalam discrete random variable. Okay. Right. So there are 68, 95, 99.7 rule. So 68% of the observation, right, will fall within one standard deviation of the mean. Means that for the first part here, this is 68% of the area. This is the rule of 68, uh, 68, 95 and 97, 99.7. This is one standard deviation. One standard deviation. When you have two standard deviation here, it covers 95% of the area. So this is two standard deviation, and this is three standard deviation. You are going to have 99.7% of the area, right? So this is 68, 95, and 99.7% rule. Based on the standard deviation. How many standard deviation you want to employ in your calculation? Normally, when you are in a manufacturing company, right, production, they are using 3 standard deviation to ensure dia punya quality of the product, right? So macam contoh, dia fill in the macam air dalam botol. So kadang-kadang mesin tu akan letak lebih sikit ataupun kurang sikit. So how many yang lebih atau berapa banyak yang kurang yang dia boleh terima untuk production for quality inspection. So normally they will based on 3 standard deviation. Nanti kita akan tengok yang beyond nanti lah. So tadi kita tengok this one is probability density function for normal distribution. So there is another term for normal distribution, which is a standard normal distribution. Standard normal distribution, right? Instead of making mu as mu, right? And let sigma as sigma x, let's say mu x and sigma x, means that this is any number. Maksudnya any real number, right? Any number. Well, instead of letting mu to become any number and sigma become any number, so it force mu means mean to be 0 and sigma to be 1. So it measure under standard normal distribution, it force mean equal to 0 and sigma equal to 1. And the standard formula we measure using Z distribution. So Z distribution means that a standard normal distribution lah. So another name is Z distribution. So you will look this again on STA 404 later on semester number 4, right? So Z distribution is equal to X minus mu divided by sigma. So we will get Z distribution, where in Z distribution we force mean to become 0 and standard deviation equal to 1. And the distribution curve would look like bell shape as well. So dia nampak macam bell shape juga. But the mean now is already become 0. And this is from negative infinity to infinity. This is a Z axis lah, right? Instead of yang sebelum ni, this one this is X axis, right? So dekat bawah ni untuk standard normal distribution, this is Z axis, right? Okay. Boleh faham the concept of standard normal distribution and normal probability distribution, right? Any questions so far regarding standard normal and probability distribution, normal distribution function? Ada soalan tak? If you don't have question, then let's look at example number 1. So example number 1, given a standard normal distribution, right? They already have a standard normal distribution. We want to find the area under curve that lies to the right of Z equal to 1.84. Maksudnya, for this one, we want to measure, this is a standard normal distribution curve. You need always draw a standard normal distribution curve to know where the area lies. So this is from negative infinity to infinity, and 1.84 to the right is this one lah, this area lah, 1.84. So we want to know what is the probability, right? The area is the probability of z more than 1.84. So what is the probability? To calculate the probability, we need to look at the statistical table, right? Statistical table, and go straight to table number 3. I believe you already have a statistical table, kan? I already provide you in Google Classroom, right? If you don't have, please find one dalam Google Classroom. So kalau kita tengok dekat sini, the description of table number 3, right? So table number 3 dia kata kat sini, we are measuring standard normal distribution, right? Sebab apa? Standard normal distribution will be greater. Will be greater means that they are measuring to the right. So dia value dalam ni dia measure to the right. So kalau kita tengok dekat sini, dia highlight, dia shade area to the right, right? So mu is a z distribution. U is x minus mu divided by sigma, and then 1 minus phi u is our probability value, right? So if you want to find this value, z is more than 1.84, it should be 1.8 dekat sini, right? Nampak sini 1.8 and 4 dekat sini. So this is the probability value, 0.0329. So this one is 0.0329. So this is the area under the curve, or the probability of z more than 1.84. Okay, ni I adjust slowly, right, to make sure you understand. Any questions so far on how to read the table? Right. So now let's look at the second question, between negative 1.97 and 0.86. So we need to draw a standard normal distribution curve, right? And this is going to be 0, negative, this is a negative infinity to infinity, right? Negative 1.97 should be on the left hand side, negative 1.97. 0.86 should be on the right hand side, 0.86. So this is the area that they want us to find, or this is the probability of negative 1.97 z and 0.86. So to find this one using a statistical table, right? So let us remember the characteristic of normal distribution. It's a symmetrical distribution, means the area on the right hand side is also equal to area on the left hand side. So kalau I buat macam ni, sama tak? Let's say I have this area 0.86. I want to measure this area minus with this area. This is negative 1.97 minus this area. So dapat tak this area? Should get, kan? Betul? So how to find this area? Sebab dalam statistical table, they give us on the right hand side, right? To find this area means that we will need to minus probability of z more than 0.86. We need to minus this area to get this area, right? Remember, the total of the area is equal to 1. It's follow the rule of probability. So this is the first part, right? Minus. So this area is also equal to this area, 1.97. Remember, the characteristic of the normal distribution, area on the right hand side is also equal to area on the left hand side. Right? Sebab apa kita nak cari this one? Because on the statistical table, they only give us area to the right. Okay? Oops. Alright. So, means that if you want to use a statistical table, then probability of Z more than 1.97. Right? So, you will get the answer lah. So, 1 minus probability of Z more than 0.8, 0.86. 6 dekat mana? Sini kan? Right? So 0.1949. So kita tulis lah 0.1949, right? Minus probability of Z more than 1.97. 1.9 is here. 7. Tarik sikit. 7 is here. 0.0244. So 0.0244. So it will become berapa? It will become this is 0.8051 minus 0.0244. It should be equal to 0.7807. Right? So there is another way to calculate the area of the probability, right? So by using a calculator lah. So if you don't have statistical table, right? I believe you already have a statistical table lah. This is another option lah. If you want to do, you want to make confirmation, right? So the step that I showed here is the step that I need in your final assessment lah, right? So if you are using calculator, you just need to confirm whatever working yang you buat ni mesti sama dengan calculator. So dalam calculator, the area, tengok betul-betul lah, this is the area of normal distribution curve, right? Dalam calculator, they are dividing into 3 area. This area we call as P area, this area we call as Q area, and this area we call as R area. So we are using 570 ES calculator, right? So first step, so let's look at the first one yang kita nak cari. Kita cari this one lah kan. What happened? The probability of negative 1.97 Z and 0.86, right? So we want to find this area 97 and 0.86, and this is 0. So how to use calculator? First step is you need to click on mode and click on statistics, number 3, right? Statistics, and dia akan keluar macam ni kan, right? And then click AC. You need to make sure dekat atas ni dia tulis stat, right? So next we need to click on shift 1 and find distribution, number 5. So they will show you PQR, right? Since we want to find the area on Q, right? So we click 2, so negative 1.97, right, plus 0.86, benda yang sama juga, Q 0.86. Nampak ada formula? So click hit equal, then you will get the answer lah. So this is going to be 0.78069. So basically in probability we round, we fit the decimal point to 4 decimal point lah. So 0.7807, benda yang sama lah, right? So how we going to do that? You gonna Q negative Q negative 1.97 plus Q 0.86. Then you will get the answer. This is we just want to confirm our calculation, right? By using calculator lah. Now let's look at example number 2. So example number 2, they already give us a standard normal distribution, right? So apa yang kita buat ni, this first 3 example ni, first 2 example ni, I just nak tunjuk you macam mana nak calculate from the area of the distribution. Once you already understand how to calculate, then we will go for the statement. Now, given a standard normal distribution, find the value k such that probability of z more than k is equal to 0.315. Right? So this one we have, satu lagi I lupa nak bagi tahu, right? Since we are in a standard normal distribution curve, it's a symmetrical distribution, kan? The area on the right hand side is also equal to area on the left hand side. And the total area is how many percent? 100%, means 1 lah. The total area is equal to 1. So means that area on the right hand side should cover 50% of the area. And this area on the left hand side is another 50%. Boleh faham? Right? So in this example, apa yang dia nak cari, we want to find the area on the right hand side which cover 0.315, and this is the value of k, right? So then to find the value of k, kita tengok dalam statistical table. Tengok dalam statistical table, dia ada dua method lah. Sama ada kita tengok dalam table ni, dalam value dalam inside the table, or we look at into table number 4. Table number 4. So dalam table number 4, kita boleh cari area of alpha. Alpha is the area lah. So our interest area is 0.315. So kalau kita tengok dekat sini, 315 tak ada dalam this table number 4 ni. So we need to look at table number 3. So area kita cari 315, and yang the nearest value to 0.315. So the nearest value is 0.3156. Right? This is the nearest value, kan? So the area of the value of k should be equal to 0.48. Boleh faham tak? Any questions so far? So I ulang sekali lagi. We want to find this area, this value, the value of k. The area of k ni to the right ni is 0.315. So kita tengok dekat table, cari the value that nearest or close to the 0.315. So paling dekat adalah 0.3156. So k, it should be 0.4 So this one, K should be 0.48 lah. Boleh faham the concept? Alright. So let's look at the next question, which is number 2. Probability of K Z less than negative 0.18 is equal to 0.4197. Right? So since the value of probability is not exceeding 0.5, maksudnya dia tidak akan pergi ke the next area, the next site lah. So it start from, this is from 0, negative 0.18 to K. K, we are expecting K to be negative K lah. Right? Negative K. K should be a negative value lah. So this is the area that we want to find. So this area is also equal to this area. Kalau kita nak guna statistical table, in our statistical table we have no negative value, right? Negative K. So it should be also equal to 0.18 to K. Right? This is same area lah. This area covers 0.4197. This area also cover for 0.4197. Okay. So how to do it? So to find this area, right? Tunjuk kat bawah sikit bagi dia. Okay, to find this area, apa kita buat? Kita ambil, which is this area, 0.18, the whole area dekat sini, minus K, area on the K. So you will get this area kan? Betul? Nampak logik dia kat situ? Nampak kan? So, apa kita nak buat? Probability of Z more than 0.18 minus probability of Z more than K is equal to 0.4197, right? So, probability of Z more than 0.18 ni, kita tengok dekat table. 0.18 is 0.4286, right? So, this one should be 0.4286 minus probability of Z more than K equal to 0.4197. Right? So, negative P Z more than K is equal to, kita bawa pergi sana, dia akan dapat 0.0089. And kita, this is negative lah. Right? Lagi besar kan? So, kita akan hapuskan negatif ni. So, probability of Z more than K is 0.0089. And remember, the value of probability cannot less than 0 and cannot more than 1. Right? It cannot contain negative value kan? So, 0.0089 kita cari dalam ni. 0.00 ada 2 0 kan? 0.0089. Okay. Paling dekat is 0.00889. So it should be 2.37. So K is equal to 2.37. But this is not our real K because we are measuring to the right hand side, kan? We are calculating on the right hand side ni kan? So to find the real K, K should be, and kita nak tengok dekat sini, should be negative 2.37. Boleh faham? Ada soalan tak? Any questions so far? So if you don't have question, then we move to example number 3. Now, this is a statement. Right, example number 3. So since you already know how to calculate the area under the curve using a standard normal distribution, so let's look at the example number 3. Given a random variable x having a normal distribution with mean equal to 50 and sigma equal to 10. And you should remember x is when x having a normal distribution, it should consist of mean and standard deviation. Standard variance, right? So when you want to convert to Z distribution, right, it should be mean equal to 0 and standard deviation equal to 1, right? So now we want to find the probability that x assume value between 45 and 62. So our mean is if equal to 50 and sigma equal to 10. We want to find probability of x between 45 and 62. Nampak ni dia tulis X kan. So now first step is we draw a normal distribution curve. This is not standard normal, this is a normal distribution curve. So mean is equal to 50. We want to know what are the area that we want to find. So the 45 on the left hand side, 62 on the right hand side. So this is the area that we want to find. Okay, now the second step is we need to convert X distribution, means a normal distribution, to Z distribution. And we need to convert this statement to standard normal distribution. Standard normal distribution is equal to X minus mu divided by sigma. This is the formula for Z, right? So probability of 45 is our x minus mu is equal to 50 divided by sigma is equal to 10. This is Z. And then 62 minus 50 divided by 10. So this one should be equal to probability of negative 0.5 Z and 1.2. So then baru kita draw a standard normal distribution. This is 0, negative 0.5, this is 1.2. Right? So, to get this answer, kita boleh draw, illustrate dalam curve lagi, macam mana kita nak cari this answer. So, we will find 1.2 area to the left, right, minus negative 0.5 to the left. 0.5 negative. So this area is also equal to area on the right, sama kan? So remember the characteristic of a standard normal distribution. So how to do that? So 1 minus probability of Z more than 1.2. This is the first part, right? For this one. This is the second part. Probability of Z more than 0.5. So this one 1 minus 0.1151. Look at the statistical table. Minus 0.3085. So you will get 0.5764. So you can calculate using calculator juga. Sama juga konsep of using calculator. Using calculator. So remember, we are finding the area of the Q. So Q negative 0.5 plus Q 1.2. So you will get the same answer as well. In calculator, you will get 0.57639. Okay? Boleh? Boleh faham? Any questions so far? So please
No,
pay
sir.
more attention on this chapter, because on our test number 2 we'll cover all chapter discrete distribution and continuous distribution as well. Right. Let's look at example number 4. Example number 4, given that X has a normal distribution with mean equal to 300 and sigma equal to 50. Find the probability of X, assume value greater than 362. So mu is equal to 300 and sigma equal to 50. We want to find probability of X more than 362. And when we draw a normal distribution curve, right, mean is equal to 300, and this is the area that we want to find, which is 362. First step is we need to convert to Z distribution. Why we need to convert to Z distribution? Because we want to refer our probability value based on statistical table. If you don't want to use a statistical table, you can use a PDF function. PDF function where you need to integrate from 362 to infinity 1 over 50, our sigma, square root of 2 pi, exponential negative x minus 300 divided by 50, right? Multiply with 2. This is square with respect to x. Then you will get the same answer lah. So if you don't want to do integration, then we use a standard normal distribution. So probability of Z is more than 362. Remember, Z is equal to x minus mu divided by sigma. So minus 300 divided by 50. Remember, kat bawah ni mesti standard deviation. If they give us the value of variance, you need to take a square root of variance. So this one should be probability of Z more than 1.24. So if you are using statistical table, you will get 1.075. If you are using calculator, this is the area of R kan? R, PQR. So you need to find R 1.24. So you will get 0.10749. Benda yang sama lah. Okay? Any questions so far? Question?
No, sir.
I tak dengar. Ada somebody nak raise question ke?
No, sir.
No, right. So let's look at example number 5. So given a normal distribution with mean equal to 40 and sigma is equal to 6, right? So we want to find the value of x that has 45% of the area to the left. So now we need to illustrate this situation by using a normal distribution curve. So to the left, 45% to the left. So this is the left hand side kan. The total area on the left is 50%. So 45% means that tak sampai 50% lah. So this is going to be the area lah. So this is the value of K that we want to find. This is 45% to the right, to the left. means that we want to find probability of x less than k equal to 0.45. And k should be on the negative value lah, negative side. Tapi kalau kita convert on standard normal, but this is not a standard normal, the mean is equal to 40, and k should be less than 40 lah, right? So first step is we need to convert to z distribution, right? Probability of z less than k minus 40 divided by 6 equal to 0.45. Right? So refer to the statistical table. 0.45, kita tengok dia sebab dia ada, kita tengok yang priority kita letak kat table number 4 dulu. 0.45 is here. Right, kita dah ada value of 0.45. So mu alpha should be 0.1257. Right? 0.45 is our alpha and mu alpha is our k kan. So 0.45, the mu alpha should be 0.1257. So k here, right, kalau kita convert a standard normal distribution, right, standard normal distribution, k over here should be negative 0.1257. Right? Betul lah? Why negative? Because it's on the negative side. Right? So, negative 0.1257 is equal to k minus 40 divided by 6. So, we take out yang dalam ni, sebab kita tahu the value of k ni adalah negative. Okay. Maybe I confuse you with the term k yang banyak sangat kan. This is the k value yang kita nak cari. But this is the, kita letak x lah, x. This is x. And the whole value here is equal to k. And the k is equal to negative 0.1257. Nampak sekarang baru clear sikit kan? Tadi nampak macam selalu sikit ada banyak k. Right, so we can solve for x. X is equal to negative 0.1257 multiplied with 6 plus 40 is equal to 39.2458. So we solve the problem. Right. For number 2, we want to find the value of x, where the area covers 14% to the right. Right. Benda yang sama je. 14% to the right. So the mean is equal to 40, and this is the area that we want to find the value of k dekat sini. And this is the value of x dekat sini. Right. X. This is 14%. So means that we want to find probability of x is more than, kita letak sebagai k lah kat sini ya. So the value of k is equal to 0.14. Right? So we convert this one to z distribution. Z more than k minus, this is x minus 40 divided by 6 equal to 0.14. Right? So 0.14, tengok dalam statistical table, do we have 0.14? We don't have, right? We don't have 0.14. So what we need to do is we look at this table number 3. Find 0.14. 0.14, the nearest is 0.1401. So the value of kx dekat sini adalah 1.08. So kalau kita convert to z distribution, ni dia dah tak nak campur lain. Okay. So this is z distribution. So the value of k here, this is 14%. K here is 1.08. Okay. So senang sajalah. Sekarang sudah senang. Kita convert lah. Do a manipulation sikit. So x minus 40 divided by 6 equal to 1.08. Right? Sebab the whole area dekat sini, the whole value dekat sini, this whole value is equal to 1.08. So x should be 1.08 multiplied with 6 plus 40 equal to 46.48. Simple question. Just want you to understand how to do a manipulation and find the area under the curve. Okay? Boleh? So, ada banyak soalan ni. Okay, kita tengok. This is a statement. Okay, statement bagus. Kita tengok statement. This is a more likely towards your final exam question lah. So, a certain type of storage battery lasts on average 3 years. 3 years with a standard deviation of 0.5 years. And okay, assuming that the battery life are normally distributed. So dia dah sebut kat sini normally distributed, okay lah. Kalau tak, dia nampak macam Poisson distribution. Remember? Okay. So find the probability that the given battery will last less than 2.3. So mu is equal to 3 and sigma is equal to 0.5. And we want to find probability of x less than 2.3. Very simple. So first step is we need to convert to z distribution. So probability of z less than 2.3 minus 3 divided by 0.5 should be equal to probability of z less than negative 1.4. So we just need to find probability of z less than 0.4, negative 1.4. Dekat sini lah the area yang kita nak cari, right? So this is going to be 0.0808. So kalau you nak guna calculator, using calculator, so we need to find P negative 1.4. Remember, dalam calculator kita divide into 3 part kan? Right? First part, second part, and third part. This is P, this is Q, this is R. So we're going to use P negative 1.4. Right? We will get the value of 0.080757. Right? Benda yang sama lah. Okay? Now let's look at example number 7. Electrical firm manufactures light bulb that have a life before burnout. So that is normally distributed with mean equal to 800 hours and standard deviation is 40 hours. So we know that mean is equal to 800 hours and standard deviation equal to 40 hours. Be careful when they tell you standard deviation or variance, right? So if they give you the value of variance, you need to find the standard deviation value by square root of variance lah. So then we need to find the probability of 778 and 834. So this is the area that we want to find, right? So mean is equal to 800. 778 is on the left and 834 is on the right. right? So second step is convert to Z distribution, right? So probability of 778 minus 800 divided by 40 Z 834 minus 800 divided by 40. So this one should be equal to probability of negative 0.55 Z. This is 0.85, right? And to find this one, right, remember tadi konsep yang sama, bawa benda yang sama, just dalam bentuk statement saja sekarang ni. We already know how to solve the problem, right? So we want to find this area. This is 0, negative infinity to infinity. This is Z distribution. So we need to find probability of, kalau kita nak fahamkan dia punya ni, paling senang kita draw another graph to illustrate how to find the curve, the area, right? So we need to find the area to the left, all the area to the left, right, which is 0.85 minus the area satu lagi, right, to the left kat sini. Then we will get area between negative 0.55 and 0.85. So this one should be 1 minus probability of Z more than 0.85 minus probability of Z more than 0.55. So this one should be 0.5111. Right? If you are using calculator, but calculator just to confirm, if you want marks in final exam, you need to show the step. You need to show the step as in statistical table, because our reference in final exam is a statistical table, not calculator. Right? Calculator, you just want to confirm your result is correct or not. Okay? So you kena faham dia punya nature jugalah. Dalam final exam, kita punya reference adalah statistical table. That's why we are emphasizing on statistical table. So if you want to find using calculator, so just to confirm whether your result is correct or not. So Q, this is a middle part kan, Q negative 0.55 plus Q 0.85. So you will get 0.51118. Right? Let's do the last question before we take a 10-minute rest. And after break, kita akan masuk normal approximation to binomial distribution and normal approximation to Poisson distribution. The last example. This is a quite difficult example. Right? But it's basically simple example jugalah, tak susah pun. So gauge are used to reject all component where certain dimension is not within the specification, 1.5 plus minus 0. Plus minus d. So it is known that measurement is normally distributed with mean is 1.5 and standard deviation 0.2. So determine the value of d, which the specification cover 95% of the measurement, mean 2 standard deviation, right? So let's draw this one. We have mu is equal to 1.5 and standard deviation is 0.2. Let's draw the situation. So always draw the situation. This is 1.5. So this is negative. This is 1. This is kecil sangat. So 1.5 minus d. This is 1.5 plus d. So this is the area that's cover 95%. right? The area cover 95%. So if kita tengok color lain. So yang tinggal dekat sini berapa persen? This is 2.5% and this is 2.5%. Remember, area on the right hand side is also equal to area on the left hand side, right? So total area dekat sini equal to 100%, right? Okay. So to find the value of D, now it's become very simple. So if you want to find value of D, probability of X more than 1.5 plus D is equal to 0.025. So kita measure on the right hand side dulu. Kalau left hand side kita tak apa, nanti kita biar dulu. Right? So now we convert to Z distribution. Probability of Z more than 1.5 plus D. This is the value of X minus mean is equal to 1.5 divided by standard deviation is 0.2 is equal to 0.025. So next, probability of Z 1.5 minus 1.5, kita tinggal apa? D divided by 0.2, right? Equal to 0.025. So kalau kita measure dalam Z distribution curve, this one should be 0 and this is the area that we want to find. D over 0.2 is 0.025. So we want to know what is the value of D divided by 0.2. So we look at the statistical table 0.025. Ada tak dalam, kita tengok parity table number 4. Table number 4, 0.025 is here. Right? Is 1.96. Right? So 1.96 is 2 standard deviation lah. So the value of this one is 1.96. And the value here, dia tak sama dekat sini. Sebab this is X, this is Z distribution. This is negative 1.96. So to find the value of D, D divided by 0.2 equal to 1.96. So then D will be 1.96 multiplied with 0.2 is 0.392. We solve the problem. So before that, I have an exercise for you. You can screenshot this one. You do it by yourself. Exercise 1. Ada banyak exercise sikit bagi kat you. You buat sendirilah to test your knowledge understanding. Right? Screenshot this one. Dah? No, exercise number 2. Exercise number 3. And that's all. Nanti kita masuk normal approximation to binomial distribution. Kita rest for 10 minutes, okay? Normal approximation to binomial distribution, right? So normal approximation to binomial distribution, when we have a binomial distribution problem, and the value of replication is too large. The n is large, and p is close to 0 or 1, right? Basically p is close to 0 lah, and we can use normal approximation to binomial distribution. As a rule of thumb, statisticians generally agree that the normal approximation should be used only when NP is more than 5 and NQ is more than or equal to 5. When these two conditions is met, then we can use normal approximation to binomial distribution. And need to remember, normal binomial distribution is a discrete random variable, and normal distribution is a continuous random variable. To convert from a discrete random variable to a continuous random variable, we need to apply a correction of continuity method. So correction of continuity method is where we add 0.5 or subtract 0.5 to the problem. Right? Now, you tengok dekat sini, correction of continuity. So, in binomial problem, when we want to find probability of x is equal to a is a number lah, right? In continuous distribution, there are no point probability. So, that's why we need to do a correction of continuity by minus 0.5 and add 0.5. When we want to find probability of x is more than or equal to a, then we need to minus 0.5. When x is more than a, we plus 0.5. This is a probability of x more than a plus 0.5, right? And when x is less than or equal to a, we plus 0.5. X is less than a, we minus 0.5. So this is what we call as a continuous correction of continuity. Right? Okay Boleh Kalau you nak screenshot pun boleh. I think in your book also have kan? Ada dalam buku ya. So the procedure. So first we need to check whether the normal approximation method can be used or not. So what is the requirement? NP and NQ should be more than 5, more than or equal to 5. And we need to find mean and standard deviation. So mean for normal binomial distribution is NP, and variance for standard deviation for normal binomial distribution is NPQ. For standard deviation or sigma, right, is equal to square root of NPQ. Right? And step number 3, we need to write the problem with the probability notation, and we apply a continuity correction factor and find the value of Z distribution and find solution. This is the sixth step. When you want to apply a normal approximation to a binomial distribution as well as normal approximation to Poisson distribution. Nanti Poisson kita tengok the second part. Now, let's look at example number 1. So, a magazine reported that 6% of American drivers read the newspaper. So, we have two outcomes: read newspaper while driving and not read newspaper while driving. So, this is the probability of success, 0.06. And if 300 drivers are selected at random, so n is equal to 300. Find the probability that exactly 25 will say that they read the newspaper while driving. So we want to find first. Let's check whether let put the notation of probability dulu lah. Let's say first is probability of x is equal to 25, right? And then we check the requirement assumption NP is equal to 0.06 multiplied with 300. So this one should be equal to 18. NQ is equal to 0.94 multiplied with 300 equal to 282. So since both NP and Q is more than or equal to 5, so we can apply normal approximation. we can apply normal approximation. Why we need to apply normal approximation? We also can use a binomial distribution formula to solve the problem, kan? Right? This is because we want to save time, right, in calculating. So we have 300. Right? We want to find 25 only, kan? Kita boleh cari jugalah, tak ada masalah. Right? Tak ada masalah. But if you want to find more than 25 or less than 300 or less than 250, then there can computation issue lah. Right? Computation issues. So that's why we convert it to normal approximation. So that's the reason lah. And the second part is we need to find mean is equal to NP, which is equal to 18. And standard deviation is equal to square root of NPQ, which is equal to 0.06 multiply with 0.94 multiply with 300 and then taking a square root. So this one should be equal to how much? Square root of 0.06 multiply with 0.94 multiply with 300. 4.11 3. So let's say we take 2 decimal point, 4.11, right? So the next number 3, we use convert. We apply continuity of correction. Apply correction of continuity, which is kalau x is equal to 25, kita tengok dia punya correction dia, we minus 0.5 and we plus 0.5, right? So this one should be probability of 25 minus 0.5 x 25 plus 0.5, which is equal to probability of 24.5 x 25.5. And number 4, convert to Z distribution. Convert to Z distribution. So we will get probability of 24.5 minus 18 divided by 4.11. This is Z. And 25.5 minus 18 divided by 4.11. So this one should be equal to probability of 1.58 Z. This is 1.82. Right. So the area that we want to find is always draw a normal distribution curve, standard normal distribution curve, to understand where is the area that we want to find. So 1.58 and 1.82. So this is on the right hand side, right? This is from negative infinity to infinity. This is Z axis. So to find this one by using a statistical table, right? So apa yang kita boleh buat? This is 1.58 this area minus this area. Right, you draw cantik 1.82. Right, so you will get this area kan. So this one should be probability of Z more than 1.58 minus probability of Z more than 1.82. So this one, look at the statistical table. Table number 3. Jangan tengok table number 4. Table number 3. 1.58. 1.58 is 0.0571. This is 0.0571 minus 1.82 is 0.0344. So this one should be equal to 0.0227. So if you want to confirm it by using calculator, so since this is on the R side kan, right? Remember dalam calculator we have three-sided, right? This is P, this is Q, and this is R. So we need to find R 1.58 minus R 1.82. So you will get 0.0226774. Okay? Boleh ada soalan tak? Before we continue to example number 2. So now let's look at example number 2. Right? Example number 2 and example number 3, I think I leave it for you. You buat sendiri. Right? Example number 2, suppose that the manager of the restaurant claimed that 70% of the customer return for another meal. So we have two outcome, return and not return. So probability of return is 0.7 and probability of not return is 0.3. So probability of success 0.70. And this is P and this is Q. In a week, 80 new customer, first time customer dine in the restaurant. What is the probability that 60 or more customer will return for another meal? So our N is equal to 80 here, right? And we want to find probability of X more than or equal to 60. Right? Probability of X more than or equal to 60. So our N equal to 80. Our P is equal to 0.7. We check the assumption. NP 0.7 multiply with 80 should be equal to 56. NQ 0.3 multiply with 80 is 24. So both are more than or equal to 5. So we can apply normal approximation. Normal approximation method. So now, our mean is equal to NP. So which is equal to 56. Our sigma is equal to NPQ, which is equal to 0.7 multiply with 0.3 multiply with 80. So this one should be, this is a square root of NPQ. Okay. So this one should be berapa? This is a 4.098. Can you calculate to confirm this one? So the next step is we want to find probability of X more than or equal to 60. We need to apply correction of continuity. Right? Apply correction of continuity. This is step number 1. So when X is more than or equal to, we need to minus 0.5. Right? When X is more than or equal to, we need to minus 0.5. So this one should be probability of X more than or equal to 59.5. So then number 2, we convert to Z distribution. So probability of Z more than or equal to 59.5 minus 56 divided by 4.098. Right? So what is the value here? 59.5 minus 56 divided by 4.098. So this one should be equal to 0.854. So probability of Z more than 0.85 lah, right? Kita ambil 2 decimal point. So 0.85 should lies on the right hand side kan? 0.85. So on the right hand side. So this is 0. This is Z distribution from negative infinity to infinity. So then we can find the value of Z. Probability value is equal to berapa? 0.85 dekat sini lah, which is 0.1977 lah. 0.1977. If you are using calculator, so R 0.85 should be, this is using calculator kan? Calculator, I show it again. Number 3, R 0.85. So 0.19766. 0.19766. Benda yang sama lah. Okay. Soalan. Any questions so far? So if you don't have question, then example number 3, can you screenshot this one and do it by yourself? I try to test your understanding. Boleh Dah screenshot Nanti nanti buat sendiri if you don't understand, you can ask me question later. For this question for this example, right? So now let's look at the next or the last part in normal approximation method, which is normal approximation to Poisson distribution, right? So as in a binomial normal approximation to binomial distribution, we have a binomial problem. For Poisson distribution, we have a Poisson problem. We want to convert it to, or we want to approximate the probability problem to normal distribution. So if X is having a Poisson distribution and lambda is large or greater than 5, then X is approximately normal distributed lah. So we understand in the characteristic of Poisson distribution, mean is equal to lambda and variance is also equal to lambda. Right, for what? For Poisson distribution, right? Remember, variance is equal to lambda. This is yeah, okay. Ada square kat sini lambda square. Oh sorry, lambda lah, bukan lambda square. Okay, good. Dia maksudnya mean is equal to lambda, variance is also equal to lambda. Remember dalam normal distribution n mu sigma squared kan? So, however, a continuity correction is required because we are approximating a discrete distribution by continuous distribution. So, we want to convert from a discrete distribution to continuous distribution lah. Okay. Understand this one? Kita ada Poisson problem. We want to convert it to normal approximation. So, bila kita boleh convert? When lambda is more than 5. When lambda is more than 5, then kita boleh convert lah, more than or equal to lah. So the concept of correction of continuity still remain same. Maksudnya when x is equal to a, then we minus 0.5 plus 0.5, and this one should be probability of x more than a plus 0.5, right? Benda yang sama lah, tak berubah pun daripada yang atas tadi. Just remember how minus 0.5 or plus 0.5. Now let's look at example number 1. So suppose that a certain automobile plan, the average number of work stoppage per day due to the equipment problem during production process is 12.0. So what is the approximate probability of having 15 or fewer work stoppage due to equipment problem on any given day? So this is a Poisson problem. We have average number of work stoppage per day. So this a count number, kan? Situation. So lambda is equal to 12. So since lambda is more than or equal to 5, we can apply normal approximation lah. So in normal approximation, mu is equal to 5 and sigma is equal to square root of 5. Right? So we want to find probability of x less than or equal to 15. Right? So first step is we apply correction of continuity. Right? So probability of x less than 15 plus or minus. This is plus or minus. It should be. Hello. Apa? Plus ke minus? Come on. Hey manusia, you tak tahu ke? Tadi ada tunjuk banyak kali dah. Plus or minus? Kalau less than 0. Less than or equal to plus 0.5 ke minus 0.5?
Is it minus, sir?
You need to screenshot this one. Right? It's a plus 0.5. It's a plus 0.5. So it should be 15.5 lah. Right? So number 2, convert to Z distribution. Right? And then this one should be Z less than or equal to 15.5 minus 15 divided by square root of 15. Right? So this one, mean is equal to, kat sini saya salah, mean is equal to 12. Lambda, the variance is equal to, the standard deviation is equal to square root of 12. Jangan confuse dengan sini ya. Right. Minus 12, minus 12. Okay, so this one probability of Z less than berapa? Can you calculate? So 15.5 minus 12 divided by square root of 12. So it should be 1.01. 1.01. So 1.01, draw the distribution curve. This is 1.01. This is 0. So definitely this one dia akan dapat lebih daripada 0.5. So we need to 1 minus probability of Z more than 1.01. So tengok dalam statistical table, 1.01 is 0.1562. So 1 minus 0.1562, right? So this one should be berapa? 1 minus 0.1562 is 0.8438. 0.8438, right? Right, let's look at the last example. Right, alright, okay. So the annual number of earthquake registered 2.5 or higher on the Richter scale and having epicenter within 40 miles of downtown Memphis follow a Poisson distribution with lambda is equal to 6.5. Calculate the exact probability that 9 or more earthquake will strike next year and compare the value to the approximation based on the center limit theorem. So lambda is 6.5, which is more than 5. We can apply normal approximation. So mu is equal to lambda, which is 6.5, and sigma is equal to square root of lambda, which is square root of 6.5. And we want to find probability of x equal to 9. So first step, apply continuity correction, probability of 8.5 x 9.5, right? And the next step is we convert this value to z distribution, probability of 8.5 minus 6.5 divided by square root of 6.5. This is z. And the next one is 9.5 minus 6.5. 6.5 divided by square root of 6.5. And then we will get probability of 0.78 z and 1.18. Okay, so the area will be on the right hand side lah. So this is 0.78 and this is 1.18, right? So we want to find the area on the right hand side. So this one should be probability of z more than 0.78 minus probability of z more than 1.18. So this one should be 0.2177 minus 0.1190. Should be equal to 0.0987. Alright. So I think that's all. Soalan tak before we end our session? Why tak record tadi? Okay. So this is how we answer the question lah. Ada soalan?
Tak ada, sir.
So if you don't have question, then I think that's all. Thank you very much. Assalamualaikum.